Alright, so in this video we're going to look at the red part of your review. Now some of these have already worked out just because there's not a whole lot that we would have done anyhow, and I'm just going to talk about how to get these answers. So for number 1, we have to find the inverse tangent of 2 in both degrees and radians. So this is just a matter of just making sure you know how to change your calculator from degree mode to radian mode and vice versa. So when it says that we want to do it in degrees, make sure your calculator's in degree mode. And just type in inverse tangent of 2 and you get 63.43 degrees. Do the same thing, do the inverse tangent of 2, but this time in make sure your calculator's in radian mode, and you get 1.11. So that'd be your answer for number 1. Now number 2, if you take the inverse cosine of negative 1.7, you get domain error. And so it's asking, why is that? Why do we get an error for that? Why is that not possible? Well, let's think about this logically. Let's think about the cosine function. The cosine function has a domain going from negative infinity to infinity and a range from negative 1 to 1. Now this is saying the inverse cosine. Now remember what's true about an inverse. The inverse, the domain, and range switch. So what was the domain is going to be the range for the inverse. What was the range is now going to be the domain for the inverse. So that means for the inverse cosine, the domain has to go from negative 1 to 1. Anything outside of that is not going to be possible. And negative 1.7 is outside of that, so that's why it's not possible. It's outside of our domain. All right, let's look at number 3. So number 3, to help us get started here, so we want to find out what values for x would be true here. So the sine of what angles would be 1/2. Now we could get this from the unit circle. So on the unit circle, at 30 degrees, because we want to do these in degrees, so at 30 degrees, the sine of 30 is 1/2. And the sine of 150 degrees is also 1/2. Now it says find all solutions. So that means every single solution that we could ever think of. So remember that this keeps repeating. We could go around this circle an infinite amount of times. So the way that we're going to write our answers is we would say one of them would be 30 degrees plus 360 degrees times k. So if I wanted to figure out what would the next one after that be, I would replace k with 1. And 30 plus 360 would be 390. I could come up with one that would be 2 further from 30 degrees. So 360 times 2 would be 720. 720 plus 30 would be 750. So that little formula there is going to give me every single angle based on that 30 degree angle there. Now there's 2 values, remember, so we have 150 degrees would be the other angle, so we're going to do the same thing. So we'd have 360 degrees plus k would give us every single answer that we could ever come up with, rotating around that circle and ending at 150. Alright, let's look at number 4. Now I already have number 4 drawn out here, but I'm going to try to break this up into piece by piece for you. Let's start with just how to solve this. And so what I notice is that we have a sign on both sides of the equation, so I'm going to group together my signs. So I subtracted 3 sine from both sides. Just like if it was an x, if I had 5x plus 1 equals 3x, I would get all the x's on one side. And I like to avoid working with negative numbers, so that's why I would subtract 3 sine from both sides to get 2 sine of theta, and then I just went ahead and subtracted 1 from both sides. We have 2 sine of theta equals negative 1. And then if I divide by 2, I have the sine of theta equals negative 1/2. And if I take the inverse, now this one we're dealing with radians, if I take the inverse sine of both sides, we get theta is negative 0.52 here, or negative 0.53. But there's a problem there. Actually, I was right, negative 0.52. But there's a problem there. Our solutions are supposed to be between 0 and 2 pi, but negative 0.52 is not within those solutions. See right there, it says find all solutions between 0 and 2 pi. But negative 0.52 is not within that region. Now, it's not wrong, it's just not in the region, or it's not in the restriction that we're looking for. And so here's what I recognize. Let's draw a graph. So again, oftentimes having a graph makes it a lot easier. Ignore everything else right now, but just focus on the red line for the sine function and where that negative 0.52 is right here. So that point, remember, it's going to repeat itself every 2 pi radians. This 2 pi, by the way, is referring to that location is 2 pi. So the distance between those two, though, so from here to here is 2 pi. So that means if I take negative 0.52 plus 2 pi, it would tell me what that other value would be at. So that's how we get the 5.76. And so 5.76 is between 0 and 2 pi. So that would be one of our solutions. Now we've got to find the other solution. So how do we find that? Well, again, what I did here is I drew this horizontal line to represent where negative 1/2 would be. So we can find out where all of our solutions are. So now I want to figure out what's this solution. Well, remember that 0.52, rather, I don't know why I put 0.53 here, but that 0.52, that was the distance here, is the same distance there from pi. So now that's just 0.52 units past pi. So if I take pi plus 0.52, that gives you your other solution. And so the other solution would be 3.66 approximately. So those would be our two, I don't know why that keeps going back in green. Those would be our two solutions, 3.66 and 5.76. So that's how you do number 4.